Okay. Okay. Today's topic is Huffman Code. This is the topic belongs to the chapter greedy technique. So first I'm going to explain why Huffman coding is required. Then we will discuss how to generate the Huffman code. And later I will explain you the concept that is generating the Huffman code with an example. Okay. First we will see what is this Huffman code and why it is required. So Huffman coding is one of the famous greedy algorithm which is designed using the concept of greedy technique. It is mainly used for the lossless compression of data. Or let me just spend 1 minute on this slide. Data compression. So data compression means compressing the huge data to the data which takes less space. So means you may have a data, it is taking some large amount of space. So I want to compress that data so that it can be stored in a less amount of space. That is called the data compression. So while you're compressing the data, you're not supposed to lose the data. Means once I compress the data, later if I want to use that data, I need to what I need the same old data. Okay, there should not be any loss while we are compressing the data. So hence it is called as the lossless compression of data. So this is one algorithm use it for data compression. So in today's class, you are going to see that how data compression is done using Huffman coding. So maybe this topic is required for later in it may appear in your next semester in the networks also. Okay, so there may be one algorithm, the same algorithm you may discuss in networks also. Okay, or maybe in this semester, I don't know. Definitely there will be a one topic in networks chapter also on this concept. Okay, first, Huffman coding uses variable length encoding method. Let me to explain what is this variable length encoding. See here, while the compression of data is doing by replacing each character of a original data by some code. For example, you may have A in the text, okay, and that A can be replaced by some code like 01, A by 01, and B by 011, or C by 10, like that. Okay. So, but it is called as a variable length encoding. It means that the length what I am using to encode the data characters is not fixed here. It is variable length. For example, to encode A, I may use only 2 characters. To encode B, I may use 3 characters. To encode C, I may use only 1 character. Okay, it all depends on the given data. Okay, hence it uses variable length encoding method. It's not fixed. Now the question is how to decide which character to take, which length of how much length of encoding. That is the question now. For example, I am telling for A you use 01. Then how to know the size for the B? How to know the size for the C? Because it is not fixed. No, the length of encoding is not fixed. It's a variable length. Okay. So I will explain you how that problem is solved in Huffman coding. Okay. So remember this issue. Okay. How to decide the length of encoding. Okay. Fine. So it assigns variable length code to all the characters. Yeah, the code length of a character depends on how frequently it occurs in the given text. Yeah, this is the line will give you solution to that issue what I have discussed it till now. I want to know the length of code of a character. Okay, that length depends on how frequently that character occurs in the given text. If the characters occurs most of the time, if its frequency is maximum, then that character is encoded with the smallest code. If the characters if the character which occurs least frequently, means less number of times in a given data, then that character gets the largest code. So this is the idea behind assigning a variable length code to the characters. For example, here you see the title of this slide. The title of the slide is Huffman Code. Okay, so here you can see H appearing only one time, U one time, and F two times, M one time, A one time, N one time, C O D E. Yeah, okay, all these characters are one time. So F frequency is 2. The character which is appearing more number of times, number of occurrences, that is what the frequency. Okay, that character will take smallest code. Okay, and the character which whose frequency is less will take largest code. So hence it is following a variable length encoding method. So you can observe the idea behind this variable length encoding. I told you this Huffman coding is used in data compression. Suppose in our original data there may be some character which appear whose frequency is maximum. Definitely, if you store the same original data in the memory, those characters appears more number of times, takes more memory. Okay. Suppose if I replace the characters which appears more number of times with the less code, with the smallest code, then definitely storing that smallest code will take less amount of memory. Hence, data is compressed, and compressed data will take less amount of memory compared to the original data. That is what the logic behind this data compression using Huffman coding method. So it is also known as Huffman encoding also. Even you can use this Huffman concept to encode the data and to decode the data also, like encryption. If you want to send some message to the receiver, you don't want to see the third party to see that message, then you need to encrypt that message. Means you need to encode that message in another form. Yes, you can use Huffman logic to even to encode the data also. So the receiver who receives that message can only understand that the received message by decoding that message. Okay, so both sender and receiver should know the logic behind Huffman coding. Means what is the code used in encoding the character. If they share that information, no, even the receiver can decode the received message, and he will learn what is the original message. Okay, fine. Uh, are you facing any problem in listening this class? If you are facing any problem, or if my explanation is not clear, you can ask me the doubts, or you can stop my explanation at any moment of time. I hope slides are clearly visible now. Yes, Rudra Prasad. If any problem in seeing the
No,
slide,
sir. No, sir.
no problem. Okay, thank
No,
you.
sir.
Okay, thank you.
Okay, sir.
Yes. Now let me to move on to the next slide. Yeah. So this is one more idea used or the rule used in the Huffman coding. A very important thing, prefix rule. So Huffman coding implements a rule known as the prefix rule. Let me explain what is this prefix rule. So prefix rule, yeah, it means that the code what you are assigning to any character in a original text is not a prefix of the code assigned to any other character. This is what the prefix rule. What is the use of this prefix rule? It prevents the ambiguity which occurs while decoding the characters. You will come to know what is that ambiguity and how what is that prefix rule later when I take the example. Let me to explain the prefix rule again with small example. Prefix rule means I told you you have to replace each character of the original data by some code. Okay, the code what you are using to encode the character should not be the prefix of any code which is assigned to any other character. For example, if I am replacing, if I am encoding A by 01 and B by 11, yes, it is valid because 01 and 11, you compare there, 01 is not a prefix of 11. So that is what the prefix rule. It is allowed. Suppose you take one more example. I am encoding A by 01 and B by 011. No, this is not allowed because code of A is 01, code of B is 011, where 01 code of A 01 is acting as a prefix of code of B 011. So this is not allowed in Huffman coding. If you allow prefixes, then you will face ambiguity problem while decoding. How? Let me to explain with an example. Assume code of A, character A is 01, code of B is 011. Now the data is AB. What is the encoded data? 01, 011. So first 01 you can replace it by A. Next again you are getting 01. You can replace that next two character also by A. No, actually it is wrong. I have to take 011, then 011 can be replaced by B. Now there is a confusion. The second occurrence of 01, shall I treat it as a code of A or shall I treat it as a part of B? That is what the ambiguity. This ambiguity will occur while decoding the characters. Hence, Huffman coding is solving this issue, ambiguity issue, by following the prefix rule. The prefix rule tells don't use a code assigned to any character. The code should not be used if it is a prefix of any other prefix of a code which is assigned to any other character. If it is not a prefix, you can use it as a code. Okay, so the major steps in Huffman coding, the first step is building a Huffman tree. So we are going to construct one Huffman tree, binary tree. Okay, it is called as a Huffman tree from the input characters, the given original data characters I am using to construct the Huffman tree. And the second step is assigning code to the characters by traversing the Huffman tree. After constructing the binary tree, I am going to traverse the tree. While I am traversing the tree, I am going to record the labels which are written on the edges, and that label will become the code for each character. And characters are stored in the nodes. Okay, you will come to know. I will explain you these steps with an example. The first step is you have to construct the Huffman tree. The second step is assigning a code to the characters by traversing the Huffman tree. While you're traversing, you need to record the labels of each and every edge which comes in the traversing path, and that record or the data or the label of the path will be the code for the character. Now let me explain how to construct Huffman tree. Okay. First, Huffman tree is a binary tree. It's a binary tree with all the left edges are labeled by 0 and all the right edges are labeled by 1. Remember this. Or in a binary tree, all the left edges are labeled by 0 and right edges are labeled by 1. Or suppose if you label the left edges by 1, then right edges should be labeled by 0. This is also allowed. You should follow any one method. Okay, either you use 0 for left edge and 1 for right edge, or 1 for left or 0 for right. Don't use both the methods. Okay, so I am following this method. Okay, I am going to label the left edges by 0 and right edges by 1. Okay, that is what the Huffman tree. Now let me to explain the steps involved in constructing the Huffman tree. So very first step is initialize n one node trees and label them with symbols of the alphabet given. So in the given data, you have assume you have 5 characters. For each and every character, you create one node tree. For example, I have A, B, C, D, E. 5 characters are there. For A, you create one node, B create one node, C create one node, and for D create one node, and for E also you create one node. And the label of that node is the character itself. Okay. And in the same node, you record the frequency of each symbol in its tree's root to indicate the tree's weight. Means for every character, I am going to write the its frequency also in the label. For example, first node is A related to A, and what is the frequency of A? Remember here, frequency means number of times A occurs in the original data. That is given in the question. Characters are also given, frequency is also given. You have to construct the Huffman tree. So very first step is for every for every character, for example, n characters are there, create n one node trees. Okay, and label the nodes. Step 2 is repeat the following operations I am going to mention in step 2. Repeat those following operations until a single tree is obtained. So what are those operations? First operation is in the step 1 we have created n one node trees. No, n one node trees are there in the step 1. Among those n one node trees, find the two trees with smallest weight. What is weight here? Weight is the frequency value. Okay, find the two trees with smallest weight. Then make them as left and right subtree of a new tree. Okay, I'm going to take, for example, I'm now A and B having the smallest weight. Assume A and B having the smallest weight. Node A and node B is taken. Node A I am going to consider as a left subtree, and node B is I am going to consider as a right subtree, and I am going to combine both the nodes to form a new tree. Okay, and the root of that new tree contains sum of the weight of the left subtree and weight of the right subtree. For example, weight of A is 2 and weight of B is 2. Now root of the new tree is 4. 2 plus 2 is 4. That is what the second step. And repeat these. You have to repeat the step 2. Repeat the following operations until you will get a single tree, because in the step 1 I have n one node trees. I have to combine all these n one node trees, n trees, into a single tree, and that single tree is a Huffman tree. In that single tree I am going to assign 0 for the left edges, 1 for the right edges. Then it will be a Huffman tree. Okay, this is what the construction of Huffman tree, the steps involved in the construction of Huffman tree. Now we will discuss with an example. You will get a question like this. Okay, very important topic and easy to understand also. There is no chances to get confusion in solving problem like this. Okay, just follow my explanation, it is enough. Okay, now the first example I am going to consider the Huffman tree. The statement is consider the 5 symbol alphabet. Okay, alphabet is given A, B, C, D, and underscore is there, underscore or minus. Okay, whatever it may be. Okay, five symbols are there in this alphabet with the following occurrence frequencies. If frequencies is also given in the question. Okay, in a text made up of these symbols. Okay, this question is given, symbols are also given and frequencies are also given. So for A, frequency is 0.35, B 0.1, and for C 0.2, and D 0.2, and underscore 0.15. Okay, the second line what you are observing is the frequencies. Okay, question here is, for this data construct the Huffman tree, and after constructing the Huffman tree, encode the given text and decode the given text. Okay, these type of questions you will get in the exam. Now let me to solve this problem. First step is I I want to construct the Huffman tree first. Now listen carefully with each and every step. Clearly, I'm going to explain you with an illustration. Okay, definitely you can understand. Listen carefully. So first step in Huffman coding is constructing the Huffman tree. So I told you for the given data, I have 5 characters here. You create 5 one node trees first. Okay, here I have created 5 one node trees. For B one node, C one node, underscore one node, D and one node, and A one node. You can observe the node is labeled with the character name and also with the frequency. B frequency is 0.1, underscore 0.15, C 0.2, D 0.2, A is 0.35. And I have arranged these nodes in the ascending order of their weights. B is the lesser value, no, least value, least frequency comes first, and A 0.35 it is the maximum. Okay, so after constructing the nodes, one node trees, arrange the nodes in the ascending order of their frequencies. Why? Because I need for the next step, I need the smallest 2 nodes. Okay, that's why. Okay, arrange the nodes in the ascending order. The second step is take 2 smallest nodes. So in 5 nodes, the two smallest nodes are B and underscore. Their weight is 0.1 and 0.15. What I have to do with these two? Yes, combine those 2 nodes, means make B as left subtree and underscore as the right subtree, and create a new tree. And the new tree is created here. You can observe here. See, for B and underscore, I have created a new tree, and its parent is a root. Now its parent label is what? 0.25. How it is 0.25? We added the weight of B and underscore. 0.1 plus 0.15 is 0.25. So that is what the label of the parent of a new tree. Okay. Now what I have to do? Observe the remaining nodes. Observe the remaining trees now. What are the remaining trees? The new tree, this is one new tree, and I have 3 one node trees, C, D, A, 3 one node trees, and this one new tree. Now again you arrange these remaining trees in the ascending order of their weights. Now I have 0.2, 0.2, then 0.25, 0.35 in the ascending order of their frequencies. Okay, next what you have to do, repeat the steps what I told you in the previous stage for the remaining trees. Now from the available trees, select the 2 minimum weighted trees. What are the 2 minimum weighted trees? C and D, because C cost is 0.2, D cost is also 0.2. Now combine C and D, create one more new tree. Yeah, C and D is taken. I'm going to combine C and D, and its cost will be the parent node cost will be 0.4. Okay, you can observe here C and D is combined, and its root, its parent value is 0.4. Now what are the remaining trees? 0.25 root as a 0.25 as a root one tree, 0.35 as a root one tree, and zero point 0.4 as another tree. Now I have 3 trees. I was having 5 trees. Now it is reduced to 3 trees. Again, take these 3 trees in the ascending order of their frequencies. Definitely 0.25 comes first, then 0.35. Now combine 0.25 and 0.35, construct one more new tree. Yeah, 0.25 lesser value compared to 0.35. Lesser value keep it in the left subtree, greater value keep it in the right subtree, and combine these two. Yeah, you can observe here I have combined 0.25, 0.35, and I got 0.6. Okay, now I have trees two trees are left. Now the 2 trees are the tree whose parent is zero point 0.4, weight is zero point 0.4, and another tree whose parent weight is zero point 0.6. Only now 5 reduced to 2 trees. Initially it was 5 one node trees. Now I have 2 trees. So now again merge these 2 trees. You observe here 0 0.4 will be the left subtree and 0 0.6 will be the right subtree, because left subtree weight should be smaller compared to right subtree. That formula we are following here. Okay, now I am going to combine these two, 0 0.4 and 0 0.6. Yes, this is the final tree. Two trees are combined into a single tree. 0 0.4 plus 0 0.6 is 1.0. So now tree construction is over. Okay, just a tree construction is over, means 5 single node trees are combined into a single tree. Okay, the tree is constructed. Now you can observe the leaf nodes, all the leaf nodes representing the characters of the given data. Okay, now what I have to do, I need to label the edges now. Already it's show I am showing the labeling in this slide already. But while you are solving the problem, now labels are not yet done. Okay, I told you the idea to label the edges. Label the left edges by 0 and right edges by 1. Okay, start from root 1.0. That is a root. Left edge labeled as 0. Good, you're going to 0 0.4. Again in 0 0.4, left edge is taking you to C, it is labeled as 0, and right edge taking you to D, labeled as 1. And next from 1.0, right edge is taking you to 0 0.6, labeled as 1, and again take 0 0.6, left edge and right edge is there, label it with 0 and 1. Next 0.25, again left right is there, left edge is labeled by 0 and right edge labeled as 1, and 0 0.6, right edge is there, taking you to A, and it's labeled as 1. Now this is a complete Huffman tree. Now I am ready with the Huffman tree. Okay, now Huffman tree is an input for encoding. Huffman tree is an input for decoding, because Huffman tree will give you the code of each character. Okay, now let me explain how to find or how to generate a code for each characters given in the present in the given data. Okay, it's very simple. You have to traverse the tree. Okay, you have to traverse the tree. Start from root is 1.0. Okay, now you don't need to worry about the weight of the node. Now for to find the code for a character, you don't need to worry about, or you don't need to consider the weight here. Just you concentrate on the labels which are written on the edges. Okay, now I want to find code for a character A. How to find that code? Very simple. Traverse the tree from root, go to the node A. So which path you are following to reach A, and label on that path, you just record the label on the on that path. That will be the code for A. Okay, now let me to find code for A. Start from the root, go right side. What is the label? 1, write 1. Just record it on a paper 1, and you are going to 0 0.6, and again go right side. Yes, what is the label on that at that edge? 1. Now I reach the character A. Stop the traversing. You see the recorded label. Recorded label is 1 1. Okay, 1 1 is the code for A. It's so simple. Clear, no? Okay, now find the code for B. How to find the code for B? Again start from root, find the path from root to B. The path is 1 0 0. Okay, 1 0 0 is the code for B. Now what is the code for C? 0 0. What is the code for D? 0 1. What is the code for underscore? 101. That's it. It's very simple. Okay, so I have calculated the code for all the 5 characters. Okay, now I am ready to encode any data or decode any data which contains these characters. Okay, yeah. So now this is the solution. The first line will tell you the characters, 5 characters. Second line is the given frequency, and third line is the code word. A code word for A is 11, B 100, C 00, D 01, and underscore 101. The third line is constructed using the Huffman tree, which is explained in the previous slide. Okay, this is what the resulting code words. Okay, now let me explain the encoding and decoding method using this solution. Okay, now I want to encode the word dad, D-A-D, dad. Okay, how you can encode? Very simple. I know the code for D, it is 01, write 01. Next letter is A, okay, character is A. What is the code for A? Write 11, okay, write 11. And next character is D, and what is its code? 01, okay, it's over. Three characters, and I got the encoded data as 011101. Okay, if you want to send this message to some the to your friend, yes, you can send, but he can see only 011101. He can understand this text as a dad only if he know the code words. Okay, you should share these code words with authenticated users only, then that users can understand the message 011101 as dad. Even you can encode your name also using Huffman coding, uh, but you have to calculate the frequency of each character and then consider the Huffman tree and then encode your name. Okay, so now let me explain decoding. Decoding. Okay, now the message is given now. 100110111011101. This message is given. I want to decode this message now. You can decode only if you know the code words. Okay, let me explain. I have the code words. Okay, now let me take one by one characters of the given message one by one. Okay, one by one character. So one first character is one. For the character one, is there any code word? Code word one is there? No. Take 10. Okay, 10 code word is there? No. Take 100. Okay, 100 code word is there. 100 represents B. Okay, write B. Okay, three characters of the given data are over. What is the next character? Next character is 1. Now don't take 1001. First three characters word that letter already we have written. And now leave those first three characters. Now start from fourth character 1. For 1, is it a code word? No. 1 is it a code? Yes, 1 is a code word. 1 is a code word for A. Okay, write A. Now leave 5 characters. Now start from 0. 0 is a code word? No. 1 is a code word? 01 is a code word? Yes, 01 is a code word for D. Okay, write D. Now leave of 3 plus 2 plus 2, 7 characters. Now start from 8th character. 8th character is 1. It's not a code word. 10. 10 also not a code word. 101. Sorry, 1 minute. Yeah, I think for 100 I have taken B, and 11 11 is about okay, yeah, I'm going correct. 11 is A, and 01 for D, it's over. Okay, next one is 101. 101 is a code word for underscore. Yes, I written underscore. Now the next characters are 11. Yes, 11 is a code for A. Write A. Next characters are 01. Yes, 01 is a code word for D. Write D. Yes. Now I decoded this message as bad ad. Okay. This is how you can use Huffman coding for encoding and decoding purpose, and even for the data compression also. So this is what the idea behind generating the Huffman codes. Okay, and use the same concept to solve the assignment question. What I'm going to post it now in the next slide. Okay, this is the assignment problem. Assignment problem. The question. I will post the message. Okay, are you, if you are so much interested, you copy this problem and try to solve it. Construct a Huffman code for the following data. Data is given. Again, the characters are ABCD underscore. Frequencies are a little bit different. Okay. Now first question is construct in the Huffman code for the following data. You have to construct tree first, then you can generate the code. And second question is encode the given message using the code of question A. And third question is decode this message using the code of question A. Okay. Yes. Yes. Yeah. If you have any doubts, you can ask me now, because still I am sharing the presentation with you people. So if you have any doubts, you can ask me. So I can visit a particular slide and I will clarify your doubts. This is about Huffman coding. Any doubts or any questions? Yes. Give the response.
No, sir.
Okay. Thank you. Now I am wait. Don't leave the class because you people are doing like this. Okay. When once I finish the class, immediately you are going to leave. You are going to left the class. Okay. Don't do like that. Okay. Fine.
Sir, I have to write question. Please, 1 minute.
Okay, okay, but I can't share it now. Anyhow, in the next 10 minutes, I'm going to post it in the Google Classroom. Okay, you access there only, huh?
Okay.
Okay, okay,
Okay, sir.
okay. Okay. Yes.